Hello everyone, my name is Garipov and I'm security researcher in Positive Technologies company. And today I'm going to show you and make some presentation about drone hijacking and playing with some IoT stuffs. Well, as I said, I'm working in Positive Technologies company and we make some solutions and research in different fields and areas of security. It's also applies to wireless and telecom security. And nowadays we're starting to play with some IoT stuff, so I'm involved in this, and today I'm going to tell you about drone hijacking. Wireless devices are widely used nowadays. They are surrounded us. Well, you can see them. They're you can see them any day in all daily life. Wireless keyboards, wireless remote controls, different stuffs, toys, as I said, keyboards. So my presentation is about SDR particularly. I think that some of you are familiar with SDRs, but some of them I think not, so I had to explain and tell you a few words about what is this SDR. SDR, it is software-defined radio, as it's written. It's very useful and unique devices. It allows you to make a lot of interesting and very cool stuff. More information you can easily find on any wiki, but just imagine yourself. You want to sniff and hijack some devices, some remote controls, some planes, make GPS spoofing, and in all these cases you need only one device, one SDR, not a scope of some transmitters and responders, just one SDR and of course software. So let's talk about some SDR market. Nowadays it's really huge market of SDRs. There are many of them, some of them well known. For example, HackerOf1. I'm sure that people who knows about SDR knows about HackerOf1 too, but not so many people know about HackerOfBlue. It's some kind of clone. It was on a Kickstarter project. Nowadays you can find clone of HackerF on some Chinese sites, and it will cost it cost will low. It's about $200. BladeRF, nice devices. You can run some solutions from Yeti, BTS, and some LTE projects on it. Nice device. Excuse me. Yes, it is UserP, not BladeRF, not HackerF. It is UserP. UserP, it's National Instruments Solutions. It's a really huge amount of devices, very interesting devices. They appear nowadays, new one. It's a very cool stuff, and here one of them, it's UserP B200. Well, cool stuff, but not so cheap one. UnterX, it's solutions from some Russian guys. Not bad device. It's this device. It's situated in some middle between BladeRF and UserP. It have got same tuner as in the BladeRF and have got nice FPGA and amplifiers, which allows you to run BTS with very big coverage from the box. So in some simple SDRs, you had to make your own amplifiers and some filters. And in this device, all in one. Nice device. Well, Airtel is there. It's a huge family of devices too. They bring new life. Then some guys from the Osmacom understand that it's not just a simple DVB-T receiver, but this receiver allows you to sniff huge range of frequencies. You can sniff GSM, DSC, and even some satellite signals with just simple cheap device which cost about $10. Nice device. If you want to start to play with SDRs and you have no money, just try to play with them. Lime SDR, well, this device appears, I think, about half a year ago. It was a crowdfunding company. It's really nice device. There are many solutions nowadays which allows you to play with different stuffs, with different software. Nice device, very small, very convenient, very useful. Highly recommended this. And there is another one device. By the way, LimeSDR produced new chipset and Lime Micro, and this is chipset is set in new LimeSDRs. The same chipset you can find on X3X. It's from Fairwaves, pretty small, very nice device. Just imagine yourself, you can make your SDR sniffer and hide it in any device, even in a laptop. These devices have got form factor of the Wi-Fi module. You can easily use it anywhere, and by the way, mini PCI interface allows you to sniff very huge range of frequencies and get a really big bandwidth. Well, I tell you a few words about devices, and let's talk about software for SDRs. I usually split these devices, this software, on three main areas. It is SDR Sharp, GQRX. This is solutions for, for simple analyzing. You can see just what happens in radio air, radio by online. You can see waterfall, make some simple demodulation, just listen radio, FM, AM, and it's pretty simple. GNU Radio and LabVIEW, it's another one kind of software solutions. These solutions allows you to make anything, absolutely, it's anything in radio. It's very flexible constructors with very huge functionality. Highly recommended to play with them. Honestly, I usually play with GNU Radio because it's open source. It's very good constructor, and I have no enough knowledge in digital signal processing, but this software, GNU Radio, allows me to play with SDRs and make some research and analysis. And Baudline, this software is very simple but very powerful in right hands. This, excuse me, Baudline, it's Baudline allows you to make any kind of analysis, but you had to have know much more about digital processing analyzing. You must be familiar with mathematics, the huge amount of mathematics inside of this, but it allows you to do a lot. Well, let's talk about what SDR allows you to do. There is a simple list of some things that you can play with NRF. You can SDR. You can play with radio, just with this simple block scheme diagram. You can make your own radio FM station. You can make some replay attacks. For example, in this case, in this diagram, presented hacking of the ring bell. Just simple replay attack, nothing more. Some flow graphs much more difficult and complicated. So, for example, it is a GSM sniffing, which allows you to make a multiplexer and make an analyzing of many channels in one scope, in one flow graph. But you had to have a really good computer to compute this online. Well, in my research, I make this scheme. It's pretty simple. It allows me to analyze some devices with GFSK modulation. I will talk about it a bit later. I will explain what is this and what this means. RFID and NFC. Imagine with radio you can play, and with SDR you can play with such kind of devices like NFC. You can make a plane tracking. It's pretty simple, pretty easy. As I said previously, you can make GPS spoofing. There are some projects with UHD and some of them for HackerF. Well, you can make some user targeting. You can analyze who around you, which devices is used You can make IMSI catchers. If you're familiar with telecom, you, I think, know what does it mean. You can make a Bluetooth low energy sniffer. You can sniff some IoT devices and etc. There are some projects of this. And of course, I think the most interesting for some people, it is BTS. Base stations can be easily run on the SDRs. There are many projects such as Asmacom BTS, Open BTS, Yati BTS, Open LTE. You can run your own LTE base station with using of SDR and software. And with the software, it will be cost you just the price of the computer and SDR. And just imagine you have got an LTE base station. Well, let's look about closer about our target. Our target is NRF24 chipset. NRF24, it's Nordic Semiconductor chipset. It's proprietary, very cheap, widely used. It can be found in a lot of devices such as remote controls, mouses, keyboards, drones, and etc. It's very widely used. It gives you a very good high speed for 2 megabit per samples, and it works on the frequency 2.4 gigahertz. It's open frequency, so this device is very good. I'm working with this device through this library. It is, you can see this library. You can, by the link below, by the link on the bottom of the slide, you can use this API. Well, I use some kind of chipset that works through the SPI interface, and you can directly work with SPI and write to registers of the device. But it's more comfortable to use API, and I use this API. By the way, there are a lot of analogs of this device, of the NRF chipset. For example, in some drones, in some quadrocopters, I find BK2423 analog. This chipset have got some additional functionality, but usually it's pretty same. Well, let's look closer to packet of the NRF24. There are usually two kinds of packets. One packet is common packet. It consists of preamble, address, payload, and CRC. CRC, it's not necessary field. It's additional field. Sometimes it not used. Address can be from 3 to 5 bytes. Well, there is another packet format. It's called short burst. But let's talk about first one, common packet. I find this using of this packet in different kind of devices. Well, NRF chipset allows you not only to transmit that data, but receive data too. It is very interesting that to sniff data, you had to put address to the target chipset to sniff area with this address. And if we want to make a sniffer on a device, we had to brute force 3 bytes of address. It's about 16 million combinations. It's too much. But there is some trick. If you read data sheet, there is some illegal instruction. You can see this. It is marked. This illegal instruction allows you to use 2 bytes of the address space. 2 bytes address space. For sniffing all 2 bytes, we had to brute force 65,000 combinations. It's already not so much, and we can make a sniffer for a few minutes, and we can sniff all devices. But there is one very interesting trick. There is a preamble in this beginning of the packet, and it is interesting that chipset doesn't look at the preamble at all. Chipset only looking for address. If chipset is tuned to receiving a data from the air and it's find correct address in the air packets, it decided to receive these packets, and it decided that this packet was to this chipset, send it to this chipset. So we make a trick. At first, we make ability to work with this illegal instruction. You should make minor changes in API of this library to write in a register this data to make the chipset works with the 2-byte address. And after that, we put in the address just data from the preamble. So we start to sniff all packets with GFSK modulation, which can be found with the preamble. So there is a sniffer. I'd like to show you on a practice how it does look like. A few seconds. Here is just a Raspberry Pi with some chipset inside. It's an RF24 chipset. As I said, it works through the SPI interface. Well, pretty simple. I connected from laptop to this device, and there is some script inside that should. Here we are. It is my Raspberry Pi with chipset, and let's start our scanner. Well, it's run, and let's look a bit closer. Let's find this remote control. Honestly, as you can read from datasheet that there are a lot of channels that can be tuned for this NRF module, but I already tuned for a correct frequency for a correct channel. Channel 9 uses in SIMA remote controls as a channel for synchronization. So I turn on it, and you see data goes. AF, AE. This is data from the remote control. This one. This is this data. So you can see how tuned my chipset for sniffing. You see that as a receiving address, I put data 00AA. 00AA, it is preamble. So a bit later, I will explain why I use 00AA. Well, this is pretty simple scanner. Main idea of this scanner is to go through the channels and find some data. So we can play with some devices. There can be some mouses, some remote controls, or keyboards, and after we just go through the channels, and after that we can see that our scanner finds devices on a channel 9 with this address, on a channel 3A with this address, and after that we can tune our chipset exactly to the device, so we can analyze exactly this device that we are going to sniff. So that is pretty simple, and but I'm not the first one who guessed about this trick with 2-byte address and preamble. Travis Goodspeed is very cool researcher, make this research much earlier. Well, unfortunately, I find his research, I think about half of a year. Only then I bought a face dancer. I find this source code. You can see godfeed.nrf. This Travis make his own solution, make his own API to work with these chipsets through the SPI interface. He even make his own board for hacking of these devices. He make a very good work for this. So let's talk about Gaussian frequency shift keying modulation. This is modulation. You can read more about it in a wiki. It's used in a lot of devices and a lot of chipsets. Well, we can see how it goes on in the radio air. Here on this picture we can see data on a channel 24. Few seconds. I can show you. It's on a real life, I think. For this, all we need is start GQRX. Oh, something terrible in the air, honestly. Very a lot of data goes through. So I think that we couldn't see remote control. But maybe we have luck. I already know in the channels in which frequencies works these solutions, so we can, I think we can find it. As I said previously, on the channel 9, you can see on the middle, yes, few seconds. I think that this is no, not this, definitely. No, we couldn't see. Oops. Yeah, we can see. You can see the spikes sometimes appears here. For example, this is our transmitter. You can see that sometimes it's higher, goes higher. Our transmitting data, but there are a lot of some devices in the air. It's not Wi-Fi. It's some kind of another transceiver. So I hope that we'll that we will see this kind of picture, but unfortunately there are a lot of devices here. Well, what about GFSK modulation? To make a bit more understanding, we should make this GNU radio scheme and make analyzing of the data what we received. After the analyzing through the baud line, we will receive such picture. I'm not sure clearly it's seen. You can see the pike on the picture below. It is starting of the transmitting. You see this part? It is starting of transmitting. It's our chipset start to works. After that, it's tuned to a frequency. This is this surface. It is then our transceiver tuned to a frequency. After that, you can see jigsaw. This part is 0 and O's. It is preamble of the packet. After that, we can see address, payload, and at the end, CRC. Well, and another pike, it is the end of the transmission. This data, our transmitter turned off. It is maybe lost connection or just turned off for a while. So in the bottom picture, you can see these explanations of this data. It is consist of 0 and 1s. This part, it is a lot of 1s. It is this part of the packet, and the end, this is CRC of the packet. You can make analyzing of the received data by your own, by your hands, not automatically. So, with these knowledges, we can make simple scheme for analyzing on a GNU radio. We make a demodulation of the received data and put this data to a FIFO channel, just in a simple FIFO file, and our scheme puts 0 and 1s to this channel, and with the simple program, we read 0 and 1s and combine it in a full packets, in the complete packets that you can see in the bottom of the part. So I can show you how it works. There is this scheme. Well, we are starting that scheme. It writes the data to a FIFO file, and here we start our GFSK finder. Few seconds. And here we see some data which can be found on the air. Let's turn on our remote control. No, this block scheme configured to sniff data from the mouse. You see, this is mouse. This is data from Microsoft mouse. First 5 bytes, A9 and etc. Till the 44. It is address. After that goes payload. Payload till 63. After that goes CRC. CRC of the NRF chipset, and 63 it is CRC inside the payload. It is additional part which is made by Microsoft firmware of the mouse. So scheme is pretty simple. You can easily configure it to sniff a remote control. I know that remote control work on another one baud rate, so and works on another channel. We know that it is channel 9, so let's tune to channel 9. Yeah. You see that there are a lot of data in this channel, but we can find our remote control. This is synchronization data of our remote control. After synchronization, after we receive synchronization, this remote control start to send data on other channels with hopping. I will show you a bit later that. Well, this is what not so cheap scanner. Why it's not so cheap? Because it's using SDR. SDR it's not $1 device. It costs about from 200, but it depends, of course, on the device. On a page day 6, we made a contest with a task to hijack a drone, and we got a winner. One guy can solve this solution, solve this task, and he can stole our drone. For this, by the link on the bottom of the slide, you can find description of this contest. For this contest, we make two kind of devices. One of them works on the Arduino, and another one, remote control, works on the Raspberry Pi. You can easily make your own universal remote control with these solutions. Well, and this our diagram, our block scheme. Once more, you can see here explanation of the data. On the top, you can see the picture from the board line with explanation of the received data. 01, it's a preamble. Before preamble, we can see that it's that our device start to transmit. It's tuned to a frequency. After that, from A2, it is already address of the device. And after that, it goes payload. So you can read about these solutions by the link. Well, a few months ago, I decided to refresh some knowledges about these solutions and find interesting open source project. It's called Deviation TX. This project allows you to make a universal remote control from just an NRF chipset and any other remote control you have. Just make some firmware for this. It is pretty simple. You can use these solutions to make your own remote control on a SDR too. It is not so difficult. So let's show you some drone hijacking. As I said previously, we know procedure of the setting and configuring of the remote control. There are two steps before remote control start to work with the drone. First, it sends a data on a channel 9 with information in which channel and which address this drone should works. So, and after that, there is a synchronization. So that's all. It is synchronized, and it is start to listen my device. But we know algorithm of the synchronization, and there are some lags of in the protocol, some misfits, and these misfits allows us to understand in which channels and with which addresses works this device. So let's again start our scanner. Few seconds, please. Oh. So we start our scanner, and we are starting to go through the channels. And on the channel 10, we can see data from remote control to a drone, to this quadrocopter. So this part is address of the device, and some guys already reversed all remotes for CMOS, and we can make our own remote control. We're putting just address of the device in which was it synchronized. It shows us in which channels it works, and you can see that this remote control still works. But as I said, we have our own remote control. Oops, I turned it off. And so original remote control wouldn't work. Thank you. Original remote control still works, and drones still receive data from this remote control, but we overload channel and send much more data. That is why our remote control have a bigger priority, have got a bigger priority. So this is not working, and this is working. So let's turn it off. And don't forget that this with previous project, as I showed before, Deviation TX, you can make a lot of remote controls. There are a lot of description. For example, after I make solution for SEMA, my colleague give me another one drone. It called Skywalker, I think, and it takes, I think, about 10 minutes to make solution for this drone too, because it works on the same chipset, but there was inverse, if I'm not mistaken, there was inverse throttle stick, but everything other was absolutely the same. So, few seconds. By the way, we can look for a data of a remote control. This is data. Few seconds. let's tune our scanner to look for this address of the device. Yes. This is a data of the few seconds. I think here. This is a packet. Sometimes I'm not a good programmer, so my program sometimes fails too often. One more time. Okay, and here we can analyze data. This is moving of the sticks. You can see first part. Yes, and this throttle, rudder, and etc. Well, so I saw the contest here that you can win the prize with SEMA. So if somebody wants to win this prize, please call me. I can teach you how you can win this. Yes, definitely. So let's talk about mouse jack attack. Researchers from Bastille Network a year ago make a white paper about mouse jack attack. This attack consists of 3 different cases. First 2 are pretty similar and not so interesting, and the third one, it is very, very interesting. Just imagine yourself. If you don't remember, I can repeat that. If you send to a mouse packet from the keyboard, this dongle allows you to receive packets from the keyboard and make a press of the keyboard. So you can send unencrypted packet as it was crafted for a mouse, as it was crafted for a keyboard, but send it to the address of the mouse, and dongle receive this packet and put it to the USB part, and there will be a pressing of the key. There was no people asked for POC. They saw just white paper without any proof of concept. So I decided to make this proof of concept for myself, and it takes not so much time. As a target, as I said, I use a mouse, keyboard, and mouse, and let's look what we have. As I said in previously, mouse accepted keyboard packets, and these packets are not encrypted. So, few seconds. Let's run our GFSK analyzer once more. Oh, I forgot. I change configuration. Few seconds. We should change bitrate to a mouse bitrate. Let's start. Here, there is data from the mouse. So, as I said previously, this is address of the mouse, and from 44 starts payload with CRC. So, you can see that we make the simple script. This script sends data to this address, to address of the mouse, first 4 bytes. It is encrypted because, well, to prove that it's not encrypted, I will show you something. You see that we can see the speed of the mouse and direction of it moves. It works not all this time because mouse have got many channels in which it works. Well, here we see this. I move and we can see the speed with directions of our moves. It is very simple packet. You can see this. 7F and FF, it's direction and speed of the mouse movement. So we make the same script with the same packet and try to make some simple fuzzing of the data inside this payload. So it was not this script. Well, it is pressing of F1 of F1K. It is make some fuzzing, try to guess the number of the packet, and always send pressing of the F1K. So yeah, we're opening a terminal. We send from the Raspberry Pi packets to a mouse dongle to a mouse address, and we received F1 packet. So that was, thank you. While we make a fuzzing, we can find that we send 1D packet, but then we make a USB HID information of the scan codes of the key presses. 1D, it is not FID, F1, but F1 it is 3A. It is because data in the packet is shifted on a 1 bit. So that it is our pressing of F1. You can understand, you can imagine yourself that we can send any data to a target. If our victim have got some kind of this dongle, some USB Microsoft, we can not only sniff data and sometimes decrypt it, but we can put data, we can send some script with get, for example, with some malicious, some virus to visit some viruses sites, and etc. And what about other devices with Gaussian frequency shift keying modulation? There are a lot of devices with GFSK modulation, as I said. It is Bluetooth Low Energy, it is Z-Wave, ZigBee, CC2500. All these devices use GFSK modulation. And for analyzing of these devices, for sniffing of these devices, all you need is just a GNU radio and this one block from GNU radio. It's called Coder 2 demodulator. All magic was done by this block. You can make simple analyzing of wireless, what goes around you. You can analyze radio air interface through just one simple block. More information and some interesting stuff we plays with Z-Wave and ZigBee you can find by the link on the bottom of the slide. There are many interesting things these dudes do with these devices. And why are we talking about GFSK? GFSK and Z-Wave, ZigBee and others are widely used. They're used in some smart kits, smart home kits, IoT kits. So you cannot hide your device. Just imagine how many devices nowadays involved in all this process. Maybe you heard about that about half a year ago. Some researchers make security issues in a light bulb from Philips. Well, and there are a lot of such bulbs, light bulb, and not only Philips. There are a lot of devices from IoT, smart hits that can be hacked by these devices, by GNU radio. You cannot. Not only you will rule in your house, but some other guys will do. So, what is the main point of all this presentation? You should understand that you must be ahead, one step before the criminals. You should make analyze, make an audit of the devices of smart kids before you implement, before you start to sell them. So let's not make mistake. Let's make audit. Let's make this world a bit more secure. Well, together, I think. So thank you for your time. Thank you. Well, maybe somebody have got questions. I will be glad to answer you, if I can. No? So, I will teach you. So if you have got any questions, you can ask me a bit later. Maybe some show and Microsoft keyboard decrypting. I can show you it. It is pretty simple. So thank you. Thank you for your time.